Good morning, my dear students. I am Mohammed Bahauddin, working as an assistant professor in ISL Engineering College, which is affiliated to Usman University, Hyderabad. So today in these sessions, we are going to learn fourth problems on the curved beam based on the crane hook of a solid circular sections. Okay, consider a crane hook. This hook made from 50 mm diameter. The diameter of this crane hook it is given as 50 mm diameter bar, loaded as shown in a figure. Determine the maximum tensile stress and specify its location. So let us observe this figure. On this crane hook, two load is acting. The first is 2 kilonewton load is acting at the top of the crane hook. The nature of the load is in tensile in nature. Again, 2 kilonewton load is acting at the bottom of this crane hook. Clear? Then, so this is the one reference point. From this one, the inner radius we are taking here 125 and outer radius we are taking as 175 mm. So, the circle of this crane hook, the circle diameter of this crane hook is given as 50 mm. Clear? So, this one we can say that this is the sections. And this line we can say that the centroidal axis line. What we can say? Centroidal axis line we can say that. The diameter of this circle is 50. Then radius should be how much dear? Half is 25 mm. Radius should be how much? 25 mm. This is our origin point. This is our origin point. If you want to measure the inner radius of this crane hook is how much is there? 75. The inner radius of this crane hook is 75. And the outer radius of this crane hook is how much is there? 125 mm. How much is there here? 125 mm. So let us see, if you want to see the distance from this end, the total distance how much is there from this end to this centroidal axis. Let us see, from here to here distance is 75 mm. Again from origin point to this inner point is again 75 mm. Again this line to the centroidal axis line is again 25 mm. So we need to add 75 plus 25, then you will get the distance x value. Clear? First, in this problem what we have to do over here? Just write down the given data in which you have to represent that the inner radius is 75 mm and outer radius is how much? 125 mm. And load P is 2 kilonewton load is acting on this crane hook, and diameter D of this crane hook is 50 mm. Clear here? After that, write down the area of cross section of a circular bar. So we have the formula is pi by 4 into d square. Pi by 4 as it is, diameter of this circle is how much is given here? 50 mm diameter is given, 50 whole square. If you divide this whole the value, then you will get the answer is 1963.5. The unit of area is millimeter square. Then this C we can see as a radius. You can, instead of C you can write here R. It is your wish. Diameter by 2. Diameter is how much is there? 50 by 2. Diameter how much is there? Diameter of the circle is 50. 50 by 2, then you will get the value of R equal to C How much we got? 25 mm. Then these are what we can say. These are we can say as radius of curvature of the centroidal axis. What we can say? The radius of curvature of the centroidal axis, we can say that. So the inner radius, how much we got here? Inner radius is 75. Inner radius from here to here is 75 plus from this end to the center point is how much is the radius? 25. Diameter of the circle is 50. Radius should be how much? 25. Clear? Inner radius is 75 plus 25. Then you will get 100 mm. Clear? After that, our main intention is there. We want to find out the bending moment. We need to find out in this problem. Okay. So, if you want to find out the bending moment about the centroidal axis, we need to find out. M is equal to load into perpendicular distance. Okay, how much load is acting on this bar is 2000 Newton load is acting on this bar into distance. Just now I told you have to measure the distance from this end to this centroidal axis line. So from here to here how much is there? 75. From here to up to this initial end is how much is there? 75. Plus from this end to the centroidal axis line is how much is there? 25. You need to add load into perpendicular distance. Load is how much is acting? 2 kilonewton load is acting at the bottom of this crane hook. 2000 into x is 75. 75 plus 75 plus 25. 75 plus 75 plus 25. If you multiply with the 2000, then you will get 350,000 Newton per mm square. After that, our main intention is there. We want to find out the distance between the centroidal axis and the neutral axis. We need to find out. So for that reason, we have to use the formula is E is equal to the radius of curvature of the centroidal axis minus the radius of curvature of the neutral axis. So radius of curvature of the centroidal axis, how much we got here? 100 mm minus C. Nothing but instead of C you can write here R square, no problem. Is it right? R, the C how much is there? C value is 25 whole square by 2 by radius. These are nothing but this is the radius of curvature of the centroidal axis. Radius of curvature of the centroidal axis is how much is there? 100 minus of 100 whole square minus of 25. If you divide this whole the value, then you will get the distance between the centroidal axis and neutral axis value is 1.5877. The unit is mm. After that, our main intention is there. We want to find out the stress because the direct tensile stress is acting as well as the compressive force is acting on this component. For that reason, what I am doing over here, first I am finding the stress because tensile stress as well as compressive stress, how much load is acting? 2 kilonewton load is acting on this component. If you see this figure here, 2 kilonewton is acting in the nature of tensile load as well as the force 2 kilonewton is load is acting in the form of compressive load. So for that reason, what I am doing over here, I am using the direct stress formula, load per unit area. How much load is acting on the crane hook? 2000 load is acting on this crane hook. By area of these cross sections of the crane of this circular section is 1963.5. If you divide this whole the value, then you will get the answer is 1.02 Newton per mm square. Okay dear, but in this case what we need to find out, our intention is there, we want to find out the maximum bending stress at the inner fiber. So maximum bending stress, it is represented by sigma bi. Sigma bi here, write down here sigma bi. Sigma here, this is the bi. Clear? Then okay dear, sigma bi equal to m into ci. So what meaning of m? M is nothing but the maximum bending moment is acting. is acting. So what about the CI? CI nothing but the distance from the neutral axis, the distance from the neutral axis to the inner fiber. Okay, so CI represent by C1 minus of E. CI is how much is there? 25 minus E is how much is that? The distance between the centroidal axis and neutral axis is how much we got it answer? 1.5877. If you subtract this value, then you will get the answer is 23.41 mm. So inner radius is the radius of curvature minus C. Radius of curvature is how much is there? 100 minus of 25. If you subtract the value, then you will get the inner radius is 75 mm. Clear? Then let us see. This is 350000 into CI, nothing but the distance between the centroidal axis, or we can say that the distance between the neutral axis to the inner surface is 23.41 by area of the cross sections of the circular bar is how much we got it here? 1963.5, and E nothing but the distance between the centroidal axis and the neutral axis, how much we got here? 1.5877, and inner radius is how much is there? 75. If you divide this whole the value, then you will get the maximum bending stress at the inner of the fiber is 35.044 Newton per mm square. So after that, our main intention is that we want to find out the total stress. We need to find out how much total stress is acting on the crane hook of a circular section. We need to find out. For that reason, what I am doing here, I am using the formula is tensile stress is equal to sigma I plus sigma D. Sigma I value is I told you sigma, instead of sigma I you have to write down sigma Bi. Here sigma Bi, maximum bending stress at the end of the surface, plus direct stress. How much we got it here is 35.044 plus direct stress value is 1.02. If you add this value, then you will get the answer is 36.064 Newton per mm square is acting at a point of 1. I hope so no one is having the doubt regarding these sessions. If you have the doubt regarding this session, please write down in the comment box, and please don't forget to subscribe my channel here. Thank you.